This is a key on the worksheet on determining end behavior of polynomial functions. And so but you basically have some problems where the function is written in general or standard form, and then you have some that are written in factored form. All right, as you work these problems, it's always a good idea to remember these general statements. All right, so for example, suppose we look at f of x equal x squared. All right, so we have the degree here. The degree of this polynomial is 2, so it's even. So the degree is even. And we know that the coefficient here is a positive number. It's positive 1, so it's a positive number. All right, and so the leading, I'm going to call this the leading coefficient, is positive. And I want you to remember this. So it's always a good idea when doing these problems to think about the quadratic function, just the basic power function, x squared. And so when you graph this, it looks like this, right? So you have a parabola where the vertex is at the origin. So when the degree is even and the coefficient is positive, the leading coefficient is positive, on the ends, the end behavior, the graph rises on both sides. So basically what that means is this: as x goes to infinity, the y value goes to infinity. So f of x goes to infinity. So meaning as x gets bigger and bigger and bigger, my y values get larger as well. Okay? My y values are approaching infinity. On this side, as x goes to negative infinity, let's think about your y values. So remember, x squared, the degree is even, coefficient is positive, the end behavior, both sides are rising. Okay? So remember, rising. So as x goes to negative infinity, my y values are increasing as well, right? They're approaching infinity. Your y values are getting bigger and bigger and bigger towards infinity. So remember, f of x means the same thing as y. So I'm going to put infinity here, okay? Now, remember, we also talked about negative x squared. So my degree is even, but my leading coefficient is negative. So if the degree is even, and the leading coefficient is negative, remember what this looks like. So remember, that was a reflection, right? The negative out here is a reflection about the x-axis. So notice the end behavior. So when the degree is even, in both cases, the end behavior are pointing in the same direction. This one's going up, this one's going down. Okay, degree even, the end behavior are pointing in the same directions. This one's going up because the leading coefficient is positive. This one is both the end behavior going down because the leading coefficient is negative. But in particular, I want you to notice this. Remember, they're both pointing down, right? The end behavior. So basically, you can say this: as x goes to infinity, your y values are going to negative infinity. So as x goes to infinity, your y values are approaching negative infinity. And the same thing on this side, because they're pointing in the same direction. So as x goes to negative infinity, meaning as x gets smaller and smaller and smaller and smaller to negative infinity, my y values are approaching negative infinity as well. Okay? So f of x approaches negative infinity. So remember, this arrow means approaches. All right, so so when looking at a function that's an even degree, always think of x squared and negative x squared. Now, for an odd function, think of this. Think of f of x equal x cubed. Okay? So if the degree is odd, remember x cubed looks like this. So that's what x cubed looks like. Looks something like this, right? So that's x cubed. Notice the end behavior. On one side it's pointing up, on the other side it's pointing down. All right, so if you know what x cubed looks like, then you will be able to do any function here that's an odd function. And so notice the degree is odd. Okay, the degree is odd. Now, if you know what x cubed looks like, and by the way, the leading coefficient is negative. I'm sorry, leading coefficient is positive, positive 1. Leading coefficient is positive. All right, so if you know what x cubed looks like, then you will be able to answer any question that has something to do with this. As x goes to infinity, as x goes to negative infinity, you'll be able to answer any question in which the degree is odd and the leading coefficient is positive. So as x goes to infinity, look at what happens to your y values. Your y values are going to infinity. So as x goes to infinity, f of x goes to infinity as well. As x goes to negative infinity, as x approaches negative infinity, okay, your y values are approaching negative infinity. So as x approaches negative infinity, f of x approaches negative infinity. And so again, notice x cubed is increasing. So rises on the right, falls on the left. Left falls, right rises. So as x goes to infinity, my y value goes to infinity. As x goes to negative infinity, my y value goes to negative infinity. And then if we look at negative x cubed, we know what that looks like. So that's a reflection. Remember, the negative out here is a reflection about the x-axis. So this part goes here. This part goes into the fourth quadrant. So we have this situation here. So this is negative x cubed. So if you know what x cubed looks like, then you automatically know what negative x cubed looks like. It's just a reflection about the x-axis. But notice again, both ends are in opposite directions, right? So as x approaches positive infinity, your y value approaches negative infinity. So remember, in this case, the degree is odd, and the leading coefficient is negative. All right. So as x approaches infinity, my y value approaches negative infinity. Okay, f of x approaches negative infinity. As x approaches negative infinity, your y value approaches positive infinity. All right, now knowing all of this, just knowing those basic functions, x squared, x cubed, negative x cubed, you are now able to answer these questions. Okay, so let's look at number 1. So when doing these, notice you have to make sure that you locate the leading term. So the leading term. So the leading term is not always the first term. The leading term is a term with the highest degree. Okay, so notice the degree of this term is 5, the degree of this term is 4, the degree of this term is 1, and the degree of a constant is 0. So this is my leading term because it's the term with the highest exponent. All these have 1 variables. So that's the term with the highest exponent. So my leading term is 3x to the 5th. All right, so from here, I know that my degree is odd, right? Degree is odd. And my leading coefficient is positive. So the degree is odd and the leading coefficient is positive. Think of x cubed. So x cubed, remember, looks like this. Once you know what x cubed looks like, then you'll be able to answer this. So it doesn't matter, remember, it does not matter what happens between the end behaviors. All I know is that for this polynomial, the end behavior on the right, my graph goes up, and on the left, my graph goes down, right? It doesn't matter what happens between them. I don't care about that. I'm only interested in those end behaviors. And I know it does that because whenever the degree is odd and my leading coefficient is positive, on the right, it rises, and on the left, it falls. So that means as x goes to positive infinity, my y values, so as x goes to positive infinity, my y values approach positive infinity. And as x goes to negative infinity, my y values go to, let me do it this way, my y values go to negative infinity as well. All right, so for this answer, you're going to say as x approaches positive infinity, I know on my right, so x approaches positive infinity means what happens on the right. What's the right behavior? So on my right, my y values approach positive infinity. Okay? And then over here, what happens on the left-hand side? What's the left-hand behavior? So as x approaches negative infinity, what happens to those y values? Those y values are approaching negative infinity as well. All right, so negative infinity. All right, so that was number one. Okay, now when we look at number two, so let's look at number two. Number two, we have this function. Let me go ahead and write it out so you can see it better. We have f of x equals negative 2x to the 7th minus 5x to the 4th. So notice that the leading term is negative 2x to the 7th because it's the one with the largest exponent. So negative 2x to the 7th. So this time I know that my degree is odd, right? So degree is odd. 7 is an odd number. And my leading coefficient is a negative 2. So my leading coefficient is negative. So when the degree is odd and the leading coefficient is negative, think of negative x cubed. So negative x cubed looks like this. So for this one, for this function, I know that the end behavior then looks like this. So the end behavior is on the left, this function is going to rise and it'll do something between them. And on the right, my function will fall. So the end behavior goes up on the left and then down on the right. Okay, so that's what this does. Okay, based on what we know from negative x cubed. On the left, my graph points up, and on the right, my graph points down. So for any, and that's going to be true for any odd function with a negative leading coefficient. So what that means is this: as x approaches infinity, my y values approach negative infinity. That's what that means. Over here, as x approaches negative infinity, my y values approach positive infinity. So f of x approaches positive infinity. All right, and so therefore, I can answer this question. So as x approaches positive infinity, my y values approaches negative infinity, based on this, right? And over here, as x approaches negative infinity, so the left-hand side, what happens to the left-hand behavior? Well, the left-hand behavior, remember, left-hand behavior, as x approaches negative infinity, my y values approaches positive infinity. All right, number three. So number three, we have this function, but notice it's not in descending order. So again, don't always assume that the leading coefficient is your first term. In this case, my leading coefficient is 5x to the 4th. So your leading term, and I didn't mean the leading coefficient, I mean the leading term. The leading term is 5x to the 4th. So the leading term is 5x to the 4th. So the degree is even, right? The degree is even. And my leading coefficient is 5. So that's positive. Leading coefficient is positive. So for that one, we're going to look at x squared. And I know that x squared looks like this. So whenever the degree is even, the end behaviors point in the same direction. So that's always easy to remember. The end behaviors point in the same direction. Either they point up or they point down. If the leading coefficient is positive, they point up. If the leading coefficient is negative, they point down. And so it's always easy to deal with a polynomial function that has a even degree. So for that one, I know this. I know that on the since the leading coefficient is positive, I know this is going to be number 3. I know that on the right it's going to go up, and on the left it's going to go up as well, no matter what happens between them. Okay, I'm only interested in those end behaviors. So as x approaches infinity, what happens to those y values? Well, those y values are approaching infinity on both sides, right? Even as x approaches negative infinity. your y values are also approaching positive infinity. All right, they're pointing up. So those y values are getting bigger and bigger and bigger. So in both cases, you're going to say infinity. All right, number 4, we have this for number 4. And so you can't read this right here very well. So let me go ahead and write it out. So this says f of x equal negative 3x to the 8th plus 3x to the 7th plus 3x to the 4th minus 7x plus 1. So you have all these terms, but for our purpose, what we're trying to find out here, all I need to know is that leading term, the one with the largest exponent. So my leading term is negative 3x to the 8th. So so the degree is even, right? So the degree is even. So we know that. But this time, the leading coefficient is negative. So the leading coefficient is negative 3. So the leading coefficient is negative. So for that one, I'm going to think of negative x squared. So negative x squared, you know, is a reflection about x squared about the x-axis. So both ends point down, right? So as x goes to infinity or negative infinity, your y values in both cases go to negative infinity. So you're going to say negative infinity. So the functions with even degree are easy to figure out. All right, so now we're getting to the point where we're looking at factored form. And remember, when doing these, you have to know what your leading term is. So the leading term and the coefficient of that leading term. And so whenever the problem is written in standard form, like they are in the first 4 problems, that's easy to figure out. It's easy to figure out what the leading term is. It's easy to figure out what the degree is and what the leading coefficient is. But when it's already in factored form, there's a little bit of work you got to do, because looking at this, that it's not in standard form, it's in factored form. So from here, you've got to figure out what that leading term is. And it's very easy to figure out that leading term. So let me remind you how to figure out that leading term. So the leading term, you're going to look at this. You can look at every factor. You're going to look at every factor, and you're going to find the leading term of each factor. So you see there are 3 factors here, 1, 2, 3. And so the leading term of that first factor is x. The leading term of that second factor, x minus 2, is also x, because remember, x to the first. Over here, x squared plus 4, x squared is my leading term. Okay? So x, remember this is all multiplication, right? X times x minus 2 times x squared plus 4. So to find the leading term, so if you were to multiply all this out, which you would not, by the way, because all you need is that leading term. You don't have to know what all these terms are. You just need to know that leading term. So to find the leading term, you just find the leading term of each of the factors, and then you multiply it out. So x times x squared is x to the 4th. And so now we have a degree is even, right? And the leading coefficient is positive. So for that case, I'm going to think of x squared. So you're going to think of x squared. I'm running out of room. So let's do this, x squared. And so notice with x squared, on both sides, the in behavior points up. So as x goes to infinity, my y value goes to infinity. As x goes to negative infinity, my y value goes to infinity as well. So infinity, infinity. All right, number 6, let's find the leading term. Okay, leading term. So number 6, let me go ahead and write number 6 over, because there's quite a few things here and I don't have enough room right here. So let me go ahead and write number 6. So here's number 6, f of x equal 3x times x squared minus 2 times x cubed minus 2x times x plus 5. All right, so notice, now you can think of this as one factor, although it's really 2 factors. It's a factor of 3 and a factor of x. But let's go ahead and look at this as one factor. You have this factor here, x squared minus 2, and you have this factor here, x cubed minus 2x, and then you have this factor here, x plus 5. All right, so from this factor, my leading term is 3x. Always make sure you write that coefficient with it. So all these coefficients here are 1s. But if that was a 2, you'd put 2x cubed as your leading term. So the coefficient must stay. Here, my leading term, for this factor, my leading term is 1x squared. Okay, so 1x squared or just x squared. Over here, my leading term is 1x cubed. So x cubed. Here, my leading term is 1x. Okay? And so we're going to multiply this out. 3x times x squared times x cubed times x. So my leading term will be 3x times x squared times x cubed times x. When you multiply like bases, remember you add exponents. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 1 is 7. All right, so my leading term is 3x to the 7. Let me go ahead and write that here. 3x to the 7. So I know that my degree is odd, okay? And my leading coefficient is positive. So since the degree is odd and my leading coefficient is positive, I'm going to use x cubed. And I know that x cubed looks like this. So on the right, it rises, and on the left, it falls. So as x goes to infinity, my y values go to infinity. So as x goes to infinity, my y value goes to infinity. As x goes to negative infinity, my y values will go to negative infinity. So remember, I know that my degree is odd. So on the right, it's going to rise, and on the left, it's going to fall. And somewhere in between, it'll do something like this, right? I don't care what happens here. I'm just, for these problems, I'm only interested in those end behaviors. What happens on the right? What happens on the left? So on the right means what happens when x approaches infinity. On the left means what happens when x approaches negative infinity. Well, when x approaches positive infinity, as x goes to the right, my y values are approaching positive infinity. Over here, as x approaches negative infinity, my y values are approaching negative infinity as well. So f of x approaches negative infinity. Okay? All right, so that's this one. And then finally, number 7. So let's go ahead and write out number 7. So number 7, we have, let's see. Let me go ahead and write it out. So we have f of x, this is 7. You have equals negative 2x times x plus 4 times x minus 7 times x squared minus 3x plus 4. All right, and so you're gonna look at each of those factors and think of this as one factor. You have this factor x plus 4, this factor x minus 7, and this factor x squared minus 3x plus 4. And you don't want to multiply this out. So, but it's easy to figure out what the leading term is. To find out what the leading term is, you take the leading term of each of those factors. So if you look at what's on the line here, my leading term, since that's a monomial, will be that monomial. Okay, that's my leading term. Now be careful. See, that's a negative, so that matters. So make sure if it's a monomial, you write that monomial over as it is. Over here, my leading term is 1x. Here, my leading term is 1x. Here, my leading term is 1x squared. And so to figure out your leading term, you're going to multiply all this out. So your leading term is going to be negative 2 times x times x times x times x squared. So again, when you multiply like bases, you add exponents. 1 plus 1 is 2, plus 1 is 3, plus 2 is 5, right? So my leading term is negative 2x to the 5th. All right, so that's your leading term, negative 2x to the 5th. So that's why it's important you keep that sign with it. All right, so your leading term is negative 2x to the 5th. So my degree is odd, right? Degree is odd. And my leading coefficient is negative. So then I'm going to use negative x cubed to help me. So when I look at negative x cubed, it looks like this, right? So on the left, it points down, and on the right, it points down, and on the left, it points up. So what that means is that as x approaches infinity, my y value approaches negative infinity, and as x approaches negative infinity, my y value approaches positive infinity. So with regards to this function here, I know that that if I were to graph this, that the graph on the right, the end behavior on the right will be pointing down, and the end behavior on the left will be pointing up. And then it'll do something between. So as x approaches infinity, which is the right behavior, my y values are approaching negative infinity. As x approaches negative infinity, which is the left behavior, my y value approaches positive infinity. So f of x approaches positive infinity. All right? And so here, you're going to say negative infinity and then positive infinity. And so that's how you do this. So that's how you're going to determine the end behavior of polynomial functions, where it's written in standard form or whether it's written in factored form. Okay? All right, so that is the key to this assignment.